Hey everyone, thanks for joining. This is Data and AI Summit 2021 conference, and we are here for a session around scaling data pipelines and beyond with Apache Spark on Kubernetes on Google Cloud. Before I begin, I would like to remind you that we are available for chat during the talk. So as questions come up, please type them in and we'll respond. And for introductions, this is Rajesh Thallam. I'm a machine learning specialist at Google Cloud, and I have my colleague and co-presenter Sougata Biswas, data analytics specialist at Google Cloud. Next slide. Today, we'll actually share with you how to effectively run Apache Spark applications on Kubernetes, specifically Google Kubernetes Engine and Google Cloud Dataproc. We'll start with understanding key traits of Apache Spark on Kubernetes and how to run these Spark jobs on Cloud Dataproc on GKE, and things to know when running Spark jobs on Kubernetes. And finally, show you a couple of implementation patterns, how Spark and Kubernetes fit in your data and machine learning pipelines. Handing it over to Sougata.
Thank you, Rajesh, for the introduction. Hi there, I am Sougata from GCP. Before getting into the core topic of running Spark on Kubernetes on GCP, let me spend some time explaining why Spark on Kubernetes. Why should you care? While Spark job can be orchestrated on various cluster managers like Yarn, Mesos, Kubernetes comes with some unique benefits. First, faster scaling. Scaling containers are much more faster than VMs. Second, isolation. Packaging all dependencies and libraries of Spark application in a container provides a great way to isolate your workload. Hence, teams can run their workload independently without blocking each other. Third, portability. Containerization of Spark application will give you the ability to run Spark application on cloud as well as on-prem. Last but not the least, cost optimization. You can utilize your existing Kubernetes infrastructure to run Spark alongside other applications without maintaining separate big data infrastructure like Hadoop clusters. Out of all cluster managers, Yarn is most popular cluster manager for Spark. So let's do a quick comparison between Yarn and Kubernetes. Kubernetes is relatively new. Yarn was supported from inception of Spark, while Kubernetes started as an experimental version from Spark 2.3 and went GA this year with Spark 3.1. In terms of feature, Kubernetes is lagging a little bit, but catching up fast. Yarn is a cluster manager for all big data applications, while Kubernetes can handle any application as long as containerization makes sense. Yarn runs on VMs or the physical machine, so scaling is relatively slower compared to containers. Now, coming to the core topic of Spark on Kubernetes on GCP, let's briefly discuss two Google Cloud products, which we'll use heavily during the presentation. One Dataproc, another GKE. So Dataproc is managed service for running big data workload on GCP. You can run many open source big data technologies like Spark, MapReduce, Presto, Hive. It has very fast spin up time. You can spin up a new cluster in almost 90 seconds. It's very cost effective when used with autoscaling with preemptible VMs. It comes with enterprise grade security. It also gives you ability to run managed jobs like workflow templates, Spark on GKE, the one we are going to show you today. In my mind, Kubernetes is new age operating system. It helps manage your application like schedule workload, monitor health, scaling up and down based on resources like an OS does. But all this done on a distributed set of machines instead of a single machine. Google has invented this and open source in 2014. However, managing Kubernetes cluster can be a daunting task. Google Kubernetes Engine, or GKE, is a managed version of Kubernetes. GKE is the easiest way to get started with Kubernetes. With few clicks, you can have a cluster up and running. GKE is fully managed product, meaning Google will handle all the work of keeping your cluster updated and healthy with SLAs. And lastly, GKE is integrated deeply with GCP. You can take advantage of not only underlying infrastructure, networking, and storage on GCP, but a lot of high-level services are well integrated with GKE. like Dataproc, the one we're going to talk about here. Now, on the core topic of how you can run Spark on Kubernetes on GCP, there are a few options, and we are going to discuss them. However, Dataproc on GKE is probably the easiest way for GCP customer to get started. Currently, it's in beta. It provides a simple API to run Spark job on GKE, which is the same API that can be used to run job on Dataproc itself. It comes with out-of-box security control, login, monitoring features. It also provides you flexibility to run custom container image. Let's say you wanted to run job with specific dependencies and libraries. You can do that. And Rajesh is going to show you how you can do that latter part of the presentation. And how this works. While Dataproc get registered with GKE, it installs an agent on GKE node. This agent makes API call to Kubernetes API servers. Then Kubernetes schedules Spark driver and executor pods on as many nodes as needed, as shown in the architecture diagram. Logs are pushed to GCP logging service. You can also run Spark on GKE directly using Spark Submit, as Kubernetes is supported as Spark native cluster manager. Or you can also use Spark operator for Kubernetes, which was open sourced by Google again a few years back. However, Dataproc on GKE makes it really simple to set up and run jobs, especially for existing Dataproc customers, as it uses same Dataproc API, which comes with all built-in features for security, logging, and monitoring.
Let's see a demo for Spark on GKE using Dataproc API. This has only 4 steps. I've already recorded it to save some time. Step 1 is to set up GKE cluster. You can use your existing GKE cluster as well, but I'm setting up a new one with autoscaling enabled, as you can see on the screen. Step 2 is to create and register a Dataproc cluster with GKE cluster, which I have created in step 1. I have also added a separate Kubernetes namespace so that Spark job can run under that namespace, which is isolated from the rest of the applications running on the same GKE cluster. Step 3 is invoking Dataproc API and submitting a Spark job. I'm running a job which reads BigQuery table from a BigQuery public datasets and doing a word count. You can see in the GKE console that it ran and logs are showing the outputs. Step 4, how do you monitor? As I said, logs are pushed to GCP login service. So you can go to GCP login service and see the log. You can also apply filters for driver and executors to see specific logs, as I'm showing on the screen. So in case if a long running job, you can also do port forwarding to see Spark OABY, as I'm showing on the screen. As I shown, it's pretty easy to run Spark on GCP, on GKE using Dataproc API. But there are a few things that you should know, and Rajesh is going to talk about those next. So Rajesh, hand it over to you.
Hope Sougata was able to convince you why you may want to run Spark on Kubernetes. But there are a few things to know to run Spark jobs effectively on Kubernetes, starting with autoscaling of Spark jobs. So if you're familiar with Cloud Dataproc, you may know that Dataproc has its own autoscaler to scale the Spark jobs dynamically. However, when running Spark jobs on Dataproc on GKE, Dataproc autoscaler is not supported yet. So instead, you would actually look at GKE cluster autoscaling, which automatically resizes node pools of GKE cluster based on the workload demand. So unlike open source Kubernetes, where cluster autoscaler works with monolithic clusters, GKE uses node pools for its cluster automation. So cluster autoscaler lets GKE use the right size instances to avoid creating too big or too small nodes utilizing the compute space. GKE's cluster autoscaler automatically resizes a number of nodes in a given node pool based on demands of your workloads. So you don't really need to manually add or remove nodes or even over provision your node pools. Instead, you just specify a minimum and maximum size for your node pool, and the rest is automated. So you can also combine GKE cluster autoscaler with horizontal pod autoscaling or vertical pod autoscaling. As you can notice here in the snippet, so when creating the GKE cluster, you actually specify those autoscaling options. So moving on, shuffle in Spark on Kubernetes. So shuffle refers to the data exchange that happens when your data is rearranged between the partitions within a Spark job. So this is required when a Spark transformation requires information from other partitions, such as aggregations or joins. So Spark gathers those required data from each of the partition and combines into a new partition, likely on a different executor. So during a shuffle, you would see that data is written to disk and transferred across the network. So as you may realize, this is actually an expensive operation, and the performance of shuffle typically depends on the disk IOPS as well as the network throughput that happens between the nodes. And specifically when you're running Spark on Kubernetes, Spark actually supports spilling shuffle data to PVCs, stands for persistent volume claims, or you can also write your shuffle data to local volumes or scratch space on the node. So you would actually get better performance when using a local SSD compared to the persistent disk. So the code here actually shows you how to configure, or basically mount local SSD to a cluster, then mount the amount of nodes, and then property when you actually submit in the Spark job. So also, we'll actually see how shuffle plays along with dynamic resource allocation, which is a slightly related topic with shuffle. So Spark actually provides a mechanism to dynamically adjust the resources of your application occupying based on the workload through a Spark job level autoscaling, which is also referred as Spark dynamic allocation. So the concept here is your application may give resources back to the cluster if they are no longer used and request them again later when there is a demand. So it's particularly useful if multiple applications share your Spark cluster resources. So Spark works in tandem with external shuffle service, and the shuffle service is mandatory for autoscaling to work. So with dynamic allocation on Yarn, you can actually enable that external shuffle service and safely enable dynamic allocation without risk of losing shuffle data when downscaling the clusters. But however, on Kubernetes, this is not possible today because Spark 3.0 does not support the external dynamic shuffle service yet. So in the meantime, there is something called soft dynamic allocation, which is available on Spark 3.0. So the way it works is Spark driver tracks the shuffle files, and it only allows to evict those executors that do not store active shuffle files. So this works actually great in practice, and also on average, the scale down of a Spark application is a bit slower compared to Yarn. So this is actually a major cost optimization technique as well on Kubernetes. So when a Spark application requests a new executor, it takes a few seconds if there is room in the cluster. If there's no room on the cluster, the cluster actually scales up and gets a new node. So as a consequence, if you are willing to trade off cost optimization for lower latency, you can actually reserve those extra resources on your Kubernetes cluster, either with over provisioning, or you can actually fine tune your GKE horizontal pod autoscaling, or even add pause pods to the cluster. Now, running Spark jobs on preemptible VMs. So if you want to optimize the cost of running Spark jobs on Kubernetes, you may want to look at running Spark jobs on a node pool with preemptible VMs on GK cluster. Preemptible VMs or PVMs are excess compute engine capacity, which lasts for a max of 24 hours, and usually there is no availability guarantee. So if your jobs are fault tolerant and can withstand possible instance preemptions, then preemptible instance can reduce your cost significantly. So the code snippet here actually shows you how you can create a GK cluster or a node pool within a GK cluster with preemptible VMs, and also the properties that you would typically set to request Spark driver and executor pods to run on PVMs. So there are a couple of caveats to note when running Spark jobs on PVMs. So PVMs can shut down inadvertently, which will cause the pods to reschedule to a new node that can add to your latency. Also, the second thing is when Spark executors with active shuffle files are shut down, those tasks will be recomputed, and which can actually add to the latency. So just be aware of the trade-off between those costs and performance when running Spark jobs on PVMs. All right, coming to the flexibility of Dataproc on GKE. So when you're using a managed service like Cloud Dataproc for Spark jobs, you may want to bring in your own Docker images or extend default images provided by Dataproc. So by default, when you create a Dataproc cluster on GKE, the default Dataproc image is used based on the image version that you're specifying. But there's a flexibility to bring in your own image or extend the default image as a container image to use when running your Spark jobs. What this means is you can actually include your own packages or even applications within a custom image when you need to. So that way you're not really bound to using the default Dataproc images. And also coming to integration with Google services like Google Cloud Storage and BigQuery. So if your Spark jobs have Google Cloud Storage or BigQuery as sources or sinks, you're actually covered. You can use a built-in cloud storage connector to store your data in Google Cloud Storage and access it directly. You don't need to transfer it to HDS or, as well as you actually have an added benefit of storing data in cloud storage, which will enable that seamless interoperability between Spark and Google services. And specifically when you're working with BigQuery as source, you would use the Spark BigQuery connector, which is an optimized connector that utilizes BigQuery storage read APIs to read Google BigQuery tables into Spark data frames. And the connector also supports writing these data frames back to BigQuery. So summarizing all things that we saw at glance, so starting with autoscaling, where you automatically resize GKE cluster node codes, then followed by shuffle, and then dynamic allocation for working with shuffle data within Spark jobs, then preemptible VMs for cost optimization, and then using custom image for flexibility, and then using the built-in connectors to integrate with Google services. Now let's see how these all play together when you're looking into the use cases or architecture patterns working with Spark on GKE. Now that you know why you want to run Spark and Kubernetes and how to run them effectively, the next question is basically how to use them when you want to implement those patterns in. So for that, let's actually look at the unified architecture for data pipelines and machine learning pipelines, or even any backend applications. So at Google, we have used a system called Borg to unify all of our processing, whether it's a data analytics workload, website, or anything else. So Borg's architecture serves as the basis for Kubernetes, which you can use to remove the need for big data silos as well. So by migrating Spark jobs to a single cluster manager, now you can actually focus on modern cloud management in Kubernetes. So at Google, having that single cluster manager system has led to more utilization of resources, providing a unified logging and management framework. So this same capability is actually available to you with Dataproc and GKE. So think of Kubernetes as not just another resource negotiator for big data processing. It's an entirely new way of approaching big data applications that can greatly improve the reliability and management of your workloads. Now, what you see here is really key because it enables you to implement the patterns like what you're seeing on the slide here. So where you have data pipelines with Spark jobs running on different versions to process your data, and then Airflow for orchestrating the pipelines, and probably a Kubeflow cluster for your machine learning task. So everything running on a single cluster manager, Kubernetes. So before we go and look at the architecture pattern, one of the key components that we'll be using in those architecture pattern is Cloud Composer. So Cloud Composer is a Google managed Apache Airflow service on Google Cloud to schedule and manage workflows. So it runs on GKE as a backend. And Composer is actually more than a wrapper around Airflow. It allows you to author end-to-end workflows on Google Cloud with integrations with our Google services and beyond. And also it gives you enterprise security for workflows. And the key is you don't really have to think about managing the infrastructure once you actually deploy your Composer environment. Now, the first pattern here, orchestrating Apache Spark jobs from Cloud Composer. So this revolves around orchestrating your data pipelines running on Apache Spark through Cloud Composer. You would write a DAG to submit a Spark job to a Dataproc cluster running on GKE. So this would actually save time by not creating and tearing down the ephemeral Dataproc cluster. So the benefit here is that you have a single cluster manager to orchestrate and process jobs. So you can efficiently use resources by having a Composer environment and Dataproc running on GKE. So think of optimizing the cost and at the same time having that better visibility and reliability into your jobs. Now let's actually see how you can expand the use case beyond data pipelines to machine learning workflows. So what you see here is a typical lifecycle outlining the major stages that a data science project goes through. So it's not a linear process, it's an iterative process that goes through multiple times, which starts with capturing data from your business processes and then combines this big data with massive processing to create machine learning models, and then validating those models for accuracy and then deploying them into production. Now, a single run of a workflow may take actually a few hours to complete. So data scientists, in the meantime, they may want to actually modify the variables or models or even model parameters to select the best combinations and then iterate through their ideas. Now let's see how Kubernetes actually fits in this lifecycle. Again, before that, let's actually talk about MLflow. So MLflow is an open source platform to manage machine learning lifecycle, including experimentation, reproducibility, and deployment through a single model registry. So MLflow offers 4 components: tracking, projects, models, and registry. So reproducibility and observability are extremely critical for iterating on your machine learning pipelines. And MLflow is actually a widely used tool for that. So expanding from that first pattern of orchestrating data pipeline, here we are actually using Cloud Composer or Airflow to orchestrate data pipelines and machine learning pipelines. The Composer is running on GKE backend, which is integrating with API connectors through Airflow operators or sensors, which may be reading data from cloud storage or BigQuery that may act as both sources and sink. So for data processing, you would actually trigger a Spark job running on Dataproc on GKE for tasks like your feature engineering or data transformations, followed by a machine learning job. So you would run those machine learning jobs to train the models, either on a Kubeflow cluster running on GKE, or you can actually go serverless with Cloud AI platform. So as we mentioned earlier, experimentation is a key aspect in a machine learning lifecycle. So MLflow running on GKE would actually allow data scientists to track experiments and deploy the best performing model for serving or inference purposes. So as you can see here, the Kubernetes or GKE becomes that infrastructure backbone, unifying machine learning and data pipeline deployments. So wrapping up, let's actually summarize what we shared with you today. So as Sougata mentioned previously, why you may actually want to run Spark on Kubernetes. So, or when actually you want to run Spark on Kubernetes. So if you have your apps running on Kubernetes clusters today, or if those Kubernetes clusters are underutilized, or if you have actually pain managing multiple cluster managers, Yarn, Kubernetes, or even Mesos, or when you have difficulties managing Spark job dependencies or Spark versions, then you may actually want to look at running Spark on Kubernetes. So with this, actually, you get the same benefits that you actually get as your applications running on Kubernetes. Think about multi-tenancy, autoscaling, and fine-grained access controls. Now, how does Dataproc on GKE fit here? And why exactly that's a solution for running Spark job on Kubernetes on Google Cloud? So there are three key reasons, I would say. One is faster scaling and reliability with enterprise security control, and the inherent benefits that you actually get out of a managed infrastructure. So with this Dataproc on GKE, you can actually optimize cost with effective resource sharing as well. And finally, we actually put together some resources here, like the blog post and some of our cloud documentation, along with some open source documentation to help you guide through how you can actually set up data and run your Spark jobs effectively on Dataproc and GKE. Before you leave, your feedback is actually important to us. Let us know how we did so that we can improve our sessions. Thanks a lot for coming to our session.